All right, if you're just tuning into the video, go ahead and take a few moments and reproduce the 6 basic graphs. I'm going to pause the video so you can too. Here goes. Gonna just remind you and refresh your memory about the basic graphs. So the first one is the squaring function. So any x value, remember anything in the parentheses, that's my x value, that is my input. Any x value I pick, I'm going to square it. Okay, so I'm just going to go through the values. I'm not writing all this down like we did last time. You can look at your notes or rewatch the video from the first section. So if I put in 0, 0 squared is 0. If I put in x is 1, 1 squared is 1. 2, 2 squared is 4. 3, 3 squared is 9. Backwards, -1 squared is 1. -2 squared is +4. And then -3 squared is +9. And so the squaring function is this cute little parabola right here, with a nice rounded bottom, and it's not pointy like the absolute value that we're going to see in just a moment. Okay, so there's my parabola. The next one, right next door, f of x is equal to the absolute value of x. So the absolute value, any input, any x value that I put in, I am going to now just make positive. So here goes. So I'm just going to pick some values again. When I put in 0, the absolute value is 0. When I put in 2, the absolute value is 2. When I put in 6, the absolute value is 6. And we could go on and on. It's very relaxing to do that. When I put in -3, the absolute value is 3. When I put in -5, the absolute value is 5. And if you remember the shape from last time, we saw that the absolute value is just a V. Both of these sides are straight, comes down to a nice pointed cusp down there at the bottom, and there's my absolute value graph. All right, sliding down the page a little bit. The next one, the cubic function. The cubic function, again, when I take my input, what I'm going to do each time, so whatever x value I pick, I am going to cube it each time. So going through the process, 0 cubed is 0, 1 cubed is 1, 2 cubed is 8. In the negative direction, -1 cubed is -1, -2 cubed is -8. And just to mention something that I mentioned last time, the only limitation to what x values I pick is what's going to fit on the graph. So if you're wondering why I didn't go beyond 2, well, when I cube 3, I'm going to get 27. And I don't have the space. I didn't pick a grid large enough to go ahead and do that. So if you want to print out graph paper, it's pretty easy to find with a quick Google search. If you want bigger grids, go for it, and you can practice with lots of other values. So there's x cubed. The last one on the front page is the square root function. The square root function says whatever input you have, whatever you're putting in for that x value, you're going to take the square root. And just a note that I gave everybody last time, let's not create excess distress for us. Pick values that are easy to take the square root of. Okay, so square root of 0 is 0. Square root of 1 is 1. Then I'm going to skip up to 4 because the square root of 4 is 2. And then last but not least, the square root of 9 is 3. I also mentioned last time, in case you weren't here, that this is the Cartesian plane. It is the real number plane. So I do not have anything over here with the values are negative. The Cartesian plane does not represent complex numbers. Okay, that's a completely different algebra. Okay, lots of fun. You can take it when you get into university. So here we go. Boom, there's my square root function. Okay. Before I turn the page, anything that you are unclear of those 4 functions? Again, I need you to be able to handle these well. Okay, on the test, you are going to be doing things with these. Okay, I'm not just going to ask you to reproduce the basic function. I'm going to ask you to do things with it. But in order to do the things with it, you have to have the function. Okay, so this is the starting place. Okay, flip the page, page 2. Okay, at the top 2, these are our other 2 basic functions. The next one is the cube root function. And similar to what I said for the square root function is I'm just going to pick values that are nice and reasonable to take the cube root of, that I don't need to worry about my calculator or anything. So the cube root of 0 is 0. The cube root of 1 is 1. The cube root of 8 is 2. The cube root of -1 is -1. Remember, we can take cube roots of negative numbers. They still are real values. And the cube root of -8 is -2. Again, my only limitation on what values I'm picking is what's going to stay on my grid. And there's my cube root function. Last but not least of our basic functions is the identity function, f of x equals x. The thing about this one is whatever the input is, whatever you're putting in the parentheses is what the output's going to be. So this one is just, we saw a straight line. When I put in 0, I get out 0. When I put in 1, I get out 1. When I put in 4, I get out 4. When I put in 7, I get out 7. Backwards, when I put in -3, I get out -3. I'm going to stop there. You're probably tired of listening to me pick values. And so again, freehand, I don't have a straight edge on me. Bad professor, but that's actually a really good freehand straight line for me. Okay, so there we go. There's my 6 basic functions, okay, reproduced. Now what we're going to do is we're going to take the next step with them, and we're going to talk about, okay, we know in math and in real life, not every function, every graph goes right through the origin, and they're moved around and they're stretched out and they're shrunk down. So what we're going to talk about today is if I have one of my basic graphs, okay, and then again, I've mentioned before, as we go through the semester, we're going to sprinkle in, I think there's 4 other basic graphs you're going to see as we go throughout the semester. This same stuff's going to apply when you learn new basic graphs. Is first thing, how do we translate things around the Cartesian plane? Okay, it's a pretty simple thing. Once you remember the basic graphs, I don't think this is going to cause you too much consternation, but here we go. So the first thing we're going to talk about as I slide down the page here is what's called vertical translations. Okay, remember the vertical direction, in case you don't remember the difference, vertical is anything that goes up and down. That's the vertical direction. Then when we get a little further, we're going to talk about horizontal. Horizontal is like the horizon. It's left and right. Okay. So vertical translations are very straightforward. I don't think anybody is going to have a problem with this. And if you do, I hope you raise your hand and let's clear it up before you go today. So before I tell you how we know a function's undergone a vertical translation, just want to remind us of a bit of notation. When you see this, and we've seen it on all these basic functions, when I write down this notation like f of x or g of x or h of x, what does that represent? What value? That represents my y value. That's just called function notation. It's just a fancy math way to write my y value. When I put in whatever x in the parentheses, the f of x or the g of x or the h of x, whatever the letter is, that is my y value. Okay, great. Now that we have that, here's my question. If I do this, if I take f of x, which you just told me is the y value, and outside of the parentheses, I write something like this, plus 5, what is happening to that y value now? Yeah, we're taking whatever the y value is. You just told me that that's the y value. We're taking whatever that y value is, and we're adding 5. So what would you guess is going to happen to the graph if I am at some y value and I add 5 to it? What's happening? It's going to go up 5. Okay, that's a vertical shift, up 5. So here's the definition on how to recognize your vertical translations. If c is just a number greater than 0, so we're just declaring here that c is a positive value, then f of x plus c represents a translation up 5 units, or not 5, c units, pardon me. I was stuck on the number 5. So f of x plus c represents a translation up c units. Translation means that the graph is firm. You're not doing anything to the graph. The shape of it is going to be exactly what it was. You are just now sliding it around the Cartesian plane. Okay, and we're going to do a bunch of examples of what this looks like. Okay, so similarly, if I have f of x minus c, well, what do you think is going to happen to the graph if I subtract a value from all my y values? Yes, exactly. That represents a translation down c units. Vertical translations. This is the most straightforward of all of the things that I'm going to do to my different graphs throughout this semester. So here's what I'd like to do. My first example, I'm going to do this one, then I've got a very similar one right next door for you. Example 1, I've given you a graph. So what I want to know is what's the equation of the function in this graph? Okay, so this is f of x is equal to something. Well, tell me from what we just did, okay, what we did at the very beginning of the class, which basic function does that look like? Okay, absolute value. And what's been done to that absolute value? What's different about this than the graph that we did on the previous page? It's moved up. So what am I going to put after my absolute value of x? Plus 4. Notice that is outside the absolute value bars. It means something different if I put the x plus 4 inside the absolute value bars. We'll get to that in a little while. But notice if this is my function, the basic function, the absolute value of x plus 4 units. So it's been moved up 4. All right, so you do the same thing. Example 2, I'm going to give you 15 seconds. Write down what the equation of that function is, please. Okay, so again, this is my function. Which one of the basic functions is it? Yeah, I didn't change that. It's still absolute value of x, but this time, what am I putting after the absolute value of x? Minus 3. Is everybody tracking with me? Are we good so far? Okay, then let's flip the page. So before we get too involved with our basic functions, example 3, I've given this check mark looking function right there. And here's what we're going to do. First thing I would like to do is identify, I want you to take a moment for me. And of this function right here, I would like you to identify what is the domain and the range of that function as it is given. Notice the edges of the function do not go to the edge of the graph, so you can assume that this one is stopping. Okay, right? It's just the way it looks. So this that I've asked you to do to identify the domain and the range, this is just what we talked about in Unit A, okay, when we introduced or reintroduced the idea of functions. The domain and the range are just my x and my y values. So the domain, left and right, what are my x values? What's the lowest x value represented on this function? Okay, -4, great. What is the largest x value represented on this function? Okay, fantastic job. Okay, we're going to put a bracket on both of those because it goes through those points. How about the range? What's the lowest y value on this? -4, and then the tallest y value? Yeah, I wasn't super creative, I guess. I probably should fix that, but that's okay. -4 to 4 in both directions. Okay. You tracking with me so far? All right, so here's what we're going to do. We're going to apply that new bit of knowledge that we just saw on the previous page, and I'm going to work this one with you. So I want to take this function, okay, this is f of x, that's what we got right here, and in purple, I'm going to do what is f of x, and let's say +5. So according to this notation, I want to know what f of x +5 is. That means I'm going to take this original function, and I'm going to do what? Add 5 to what? All the y values. Yes, if you said that, I'm sorry, I didn't hear. Okay, so we're going to take 5 and add it to all the y values. So what I'm going to do is I'm just going to pick some representative y values because remember, in translations, the shape of the graph does not change. Okay, so the graph I have, basically, if I had the ability, if I could slide this red check mark, I would just slide it upward 5 units. Okay, so here's what I'm going to do. I'm going to go onto this left end and I'm going to count up 5. 1, 2, 3, 4, 5. I'm going to make a dot. I'm going to go to this peak right here on the left and I'm going to go 1, 2, 3, 4, 5. I'm going to make a dot. I'm going to go down to this low point right here and I'm going to go 1, 2, 3, 4, 5. Make a dot. And then over on the right side at that other end, I'm going to go 1, 2, 3, 4, 5 and make a dot. And now I'm just going to connect the dots because, and I'll repeat this several times because I don't want there to be any confusion about this. Translations do not change the shape of the graph. You should have the exact same looking graph that has just been slid 5 units up the Cartesian plane. Does that seem pretty reasonable? All right, well, before we move on, let's look at that purple graph. Let's identify now what is the domain and the range of the new graph. We'll use the graph for this, but then I'll show you that if you don't have a graph and you don't need it, it's pretty easy to identify the domain and the range and how it works. So the domain, left and right, has the domain of this graph changed at all? No, because I haven't moved it left and right, correct? Does that seem reasonable? I just went straight up. So the x values do not change. So -4 to 4. But the y values have changed. Now, on my purple graph, what is the lowest y value? 1. What is the largest y value? Okay, great. And that should seem pretty clear. Look at the original domain and the range. The original domain was -4 to 4. We didn't move the graph left or right, so it stayed -4 to 4. But notice the original range was -4 to 4. That the new one's 1 to 9. It's the same thing I would get if I just said, okay, I'm going to add 5 to each endpoint here. So if I add 5 to -4, I get 1. If I add 5 to 4, I get 9. Okay, so if you don't have the graph, which there's a couple questions on your homework that are like that, you're just given either the domain or range and said, how does this translation affect it? You can just add to whatever direction is appropriate. So here's what I would like you to do. Right next door is example 4. So I want you to do the same thing. First, I want you to identify the domain and the range of the original function. And then I would like you to graph, this graph I just called g of x, just to be creative and different. So I would like you to do what g of x minus 6 is. And then identify the domain and the range of g of x minus 6. If you need any help, wave your hand. I'll get to as many of you as I can. It's a big class, but I'll try my best. So I'm going to get started. If you're still working, keep working. You can check your answer with mine when we're both done. So the domain of this that I ask you to identify first, the furthest left this goes again is -4 like the last graph, and the furthest right this goes is +4, and I'm going to put some brackets there. My range, the furthest down this goes is -3, so I got super creative and changed the number, and then the furthest up this goes is +3. Anybody get something different that we need to talk about? Don't be afraid to speak. Okay, you got a weekend that you're gonna spend with your algebra in my math lab, and I want it to go well for you. Is that a question, or what did you get? Okay, so down here, this is, I'm just gonna kind of go over here like that, and that is 1, 2, 3 units down. So that's why that is down -3. Okay, the top one up here is at 1, 2, 3. Okay, so it's however far up or down the graph goes, wherever that happens, the furthest point in the y direction, wherever it is, whether it's in the middle of the graph or on the ends of the graph, that's what determines the range. Okay. Great question. Glad we got hopefully got some clarity there. Okay, so now what I'm going to do is I'm going to take that graph that we have and we're going to take the whole thing -6. So I'm just going to identify some points here. So here on the left, I'm going to drop that down 6. So 1, 2, 3, 4, 5, 6. Boom. This top part that's at 3 right here. 1, 2, 3, 4, 5, 6. I'm going to, since it goes through the origin, that's going to be fine. 1, 2, 3, 4, 5, 6. At the bottom, this trough right here, 1, 2, 3, 4, 5, 6. And last but not least, 1, 2, 3, 4, 5, 6. If there's other points you did, that's fine, but I've got enough of a sample there that I'll be able to reproduce the shape. So here we go. Looks something like close enough. Okay, we get the gist. Okay, that's down 6. It's the same graph. I've just slid the graph down 6. So now the domain and the range, again, I've not moved this graph left or right at all. So the domain, as you can see from the graph, stays the same. And then the range should agree with this, is what I get when I just subtract 3 from each end of the original range. So when I subtract 6 from each end of the original range, so that should be -9 to -3. Well, let's confirm that. Let's see, this right here, that is at the value -9. That's great. And then this top dot right here is at the value -3. So good, we've got the same thing that the graph got, confirmation. Example 5, h of x. I'm not worried about the domain and the range. We've done that a couple times. If you feel unsure about identifying domain and range, you can do it and I'll come check it for you. But if you feel all right about finding domain and range, all I want you to do is take that graph right there, and I'd like to know what h of x plus 3 would look like. So I'm going to take that green graph and I'm going to find some representative points and I'm going to move them up 3 units. So the left side over here up 3, 1, 2, 3. This point where it turns, I'm going to go 1, 2, 3 up. The origin, I'm going to do that 1, 2, 3 up. This bottom point here, 1, 2, 3 up. And then this other end point, 1, 2, 3 up. And so again, a translation does not change the shape of the graph. And I did a pretty good job of reproducing that. One more, and then we're going to turn our attention real quick to just one of the basic graphs, and then we will do the other type of translation. So if you got any questions about vertical translations, bring them up. Okay, now is the time. So example 6, k of x. You can see that nice large graph right there. Why don't we do k of x, and then let's do, just for cuteness sake, let's do -4. just going to take this graph that we have. I'm going to slide all the y values down 4. So this one that's on the end, 1, 2, 3, 4 down. This bottom point, 1, 2, 3, 4 down. This point up here where it turns, 1, 2, 3, 4 down. And last but not least, this other end, 1, 2, 3, 4 down. And so then my graph's going to look like this. The shape is going to be unchanged. Any variations in shape are just due to my unsteady hand. There we go. I did tell you a while back, if you forgot this, it is not a big deal. But on the graphing, the thing I used to produce the graphs, for some reason, it doesn't have arrows for me. So if you remember, I told you whenever anything goes off the sides like that, it's going in that direction. So if I had asked you for the domain and the range, but I'm gentle with taking off any points about that because I know it's not always easy to remember that. Okay, one more thing we're going to do before we go to the horizontal translations. Go back to page 1, please. And we're going to look at the square root graph. And here's what I would like you to do with the square root graph. We're going to do 2 things. I want you to please graph for me these 2 things, and you can do it all on the same grid. I would like you to do the square root of x, and then outside of the square root, we've got +1. And then I would like you to go back and do the square root of x, and let's go -7. Again, those are both outside the square root. So this is why it's handy to remember or be able to plot those basic points, because now when I have to translate, or later when we come back next week and we start stretching and shrinking, where we base it on these points that we know we can see. So when I go up 1, I take the origin up 1. When I take this point up 1, here up 1, and then over here in the end up 1. And so my new graph, again, the shape does not change, just where it's translated to. Then if I do the same thing down 7, so I go 1, 2, 3, 4, 5, 6, 7 down, so right here, and then 1, 2, 3, 4, 5, 6, 7 down, 2, 3, 4, 5, 6, 7, and then lastly 3, 4, 5, 6, 7, and here's that graph of the square root of x -7. How do we feel about vertical translations? We good? Vertical translations, very straightforward. It's exactly how it looks. When it's +1, you go up 1. When it's minus, you go down. Okay, so that is as opposed to, there is a little bit of a hiccup here when we talk about horizontal translations. So horizontal, the horizon, this means translations that are going to go left or right. So again, we start off similarly to the last one. If c is greater than 0, meaning c is a positive number, then f of x minus c represents a translation. Now notice my notation. My c is now being subtracted directly from the x. That's what tells you it's going to be horizontal. It's affecting the x's because it's in there with the x. Okay, so do you notice the difference in notation versus the last one? That was outside the function. Okay. Now here's the kicker. I know what we all want to say. When I learned this way back, long time ago in the 80s, I wanted to do the exact same thing until Miss Hilliard totally demanded the opposite. F of x minus c, I know you want to go in the negative x direction because it's a minus, but that's not how the horizontal translations work. Okay, you got to think about this. If you want a sort of simple explanation, you think about it, what makes this in here 0. And it would be a positive c minus c would give you 0. Okay, that would take you to your home point. And so when you have f of x minus c, that represents a translation right or in the positive direction, c units. And by the way, this is true of stretching and shrinking. Anything that happens in the horizontal direction is the exact opposite of what it looks like. It's a minus c here, so you're going to go in the positive direction. Similarly, if I have f of x plus c, so I'm adding c directly to the x, again, I understand what that looks like and what your impulse is, so you've got to untrain yourself. This represents a translation left in the negative direction, c units. It's the exact opposite of what it looks like. And I understand that that's goofy. That's why we're going to do a bunch of examples to make sure that we catch on to that one little thing that's going on. We good on writing that down? I don't want to fast forward if anybody's not ready. Okay, well, at the top of the next page then, I'm going to do example 7 with you. Example 7 is how we started off with the vertical translations. I've given you a graph based on one of our basic functions, and we are going to represent it as a function. So this is f of x. Which one of my basic functions is this? It's the x squared function. Now, what's happened to the x squared function right there? It's gone right or in the positive direction 4 units. So because of that, here's what we do. We say this is going to be x minus 4. Okay, remember, it's the exact opposite of what you think. We've gone in the positive direction, so it's x minus 4 in parentheses squared. So notice the difference in notation. When you're doing things right or left, that value that you're adding or subtracting is right in there grouped with the x. Okay, that's very important, because I don't want you to accidentally communicate something that you don't mean to. All right, we'll do the same thing right next door, example 8. I won't even ask you to tell me that that's the square function again. Okay, so it's the square function again. What's happened to this graph? It's gone where? Okay, it's gone less 6. And what did you say? Okay, so this is going to be x plus 6 in parentheses squared. All right, so I'm going to do with you example 9. Okay, so I'm taking my time. If I'm losing anybody, let me know. I understand the horizontal translations take a minute more to get the handle of. So here is example 9. It's the same thing that we did earlier with example 3. So I'm just going to copy over the domain and the range of this original function. Okay, it's the same as the domain and the range the first time we did this problem. So the domain of this is -4 to 4. Okay, you can identify it again if you need to, but I'm just copying from example 3, -4 to 4 in the y direction. So here's what we're going to do. We're going to do this together. I want to know, I'm going to write this down at the bottom of the graph just so that I don't make a big mess up there. What we're going to do is I'm not going to do it in red because that's the color that's already there. All right, we are going to do f, and in parentheses, x minus 3. All right, so I've got the x minus 3. That minus 3 is in the parentheses with the x. That's how you know it's affecting the x, or in other words, it's a horizontal translation. So what is going on with this one? Which way is the graph going? It's going right. How many units? Great, thank you very much. I'm just going to make that note down there because I know how I know how when you leave here, your short-term memory is going to get foggy. So I want you to have everything you need when you're going through your weekend. So I'm just going to move just like we did for the vertical. I'm just going to move the key points right 3 units. So up here, 1, 2, 3, boom, 1, 2, 3. The origin, 1, 2, 3. 1, 2, 3, and then last but not least, 1, 2, 3. There we go. Again, translations do not affect the shape of the graph. They just affect their location. And there it is. Again, just like last time, just because it's our first problem, we're just going to identify the domain and the range, and you're going to do the same on your first problem. So the domain and the range. Well, looking at the graph, what's the lowest x value on the graph? Sure, -1. What's the largest x value? It's going to be 5, 6, 7. That's going to be 7. I have not moved this graph up or down at all. So in this one, the range stays the same as it was. And again, just like before, I'm just making this little point to you. If you don't have the graph and you're asked how the domain and the range change, remember, we're only going in the x direction, right 3. So I can add 3 to each end of the domain. So when I add 3 to -4, I get -1. When I add 3 to 4, I get 7. And there we go. There we have our domain and our range. So I would like you to do the same thing. Example 10, you can copy over the domain and the range from the previous, I think it was example 4 on the other page. And then what I would like you to do is, what is the graph and what is the domain and the range of g of x plus 5? Right, so the x plus 5 in parentheses tells me what's going on with this graph. It's going to go left, or the negative direction, 5. So I'm going to move my points left. So left 5 here is 1, 2, 3, 4, 5 to -9. And then 1, 2, 3, 4, 5. Origin 1, 2, 3, 4, 5. Down here, 1, 2, 3, 4, 5. And last but not least, 1, 2, 3, 4, 5. And there is my graph that has been moved left 5. Not too shabby on tracing it. That looks great. And then my domain and my range. Okay, you can either do this by looking at the graph, or you can adjust the other graph's domain and range. When I subtract 5, I go from -9 to -1. And then the range does not change because I've not moved the graph up or down at all. I'm flipping the page. Example 11, what I would like you to do on that one. Again, if you want to do the domain and the range, that's up to you. I'm not worried about it. If you want me to look at your domain and range, that's fine. What I would like you to do is construct the graph of h of x minus 5. right, so the x minus 5 in parentheses does what with this graph? To the right 5, yes, in the positive direction. So right 5. So I'm going to take each of my points. So 1, 2, 3, 4, 5 takes that to 10. 1, 2, 3, 4, 5. The origin 1, 2, 3, 4, 5. This point right here 1, 2, 3, 4, 5. And finally, this other end point 1, 2, 3. So I miscounted 1, 2, 3, 4, 5. There we go. That's better. And so here we go. Connecting the dots. Excellent. All right, one more. And then we'll go to one of our basic graphs, and then we're going to finish with a flourish. Okay, very exciting. So I would do on example 12, what I would like you to do is k of x plus 1. All right, so this one, the x plus 1, that's going to move the whole thing left 1, meaning the negative direction. And so I'll do that. I'm off the graph a little bit over here, so sorry about that. And then here, and then the origin, everything's going left 1. So then this is not really an endpoint, it's an arrow, but if you thought it was an endpoint, I'll move that there. So here we go. This is just going to be this. I'm going to put an arrow here because it's still going on forever and ever. And then there's my graph. Everything's just been moved left 1 unit. Okay, one more of these just one translation problem. So go back to the front page for me. We're going to look at the cubic function down at the bottom. And what I would like you to do, please, on the cubic function is I'd like you to graph what x minus 3 in parentheses cubed is. All right, so again, the x minus 3, just one more time, just to make me happy. What's happening to this graph? It's going to the right 3 units. Yes, right 3, positive, the positive x direction, right 3. So I'm just going to take each of my basic points that I identified, and I'm going to go 3. So 1, 2, 3, boom. And then 1, 2, 3, the origin, 1, 2, 3. This point right here, 1, 2, 3. Oh, yeah. And then 1, 2, 3. There we go. And woohoo. There it is. Any problems? Anything we need to talk about before we finish with a flourish? All right, well, you know, it wouldn't be a day in the Perksters class if I didn't goof something up. So here's what I did. I was replacing the graphs because I took the time this morning to make fancy computer-generated ones, and then I forgot to insert them on these next 2 problems, 13 and 14. So the graph from exercise 9, example 9, we're going to copy over. Okay, I'll tell you what points to do. If you're watching on video, I will have fixed this by the time you watch the video, so don't worry. So here are the points you're going to do. This is just the basic graph. So you're going to go back -4, +1. Make your first point at -4, +1. The next point is -2, +2, or excuse me, -2, +4. Then we've got the origin, 0, 0. Then we've got 2, -4. And then finally, we've got 4, -2. This is just the graph we were using before. I just goofed it up. I didn't copy and paste. Okay, so that should be the same graph we were using before. It should look just the same. Let me just verify that I didn't goof up again. Oh yeah, okay, we're 100% there. Okay, so here's what we're gonna do. We've already identified the domain and the range of this function a couple times, so I'm just gonna rewrite that here. No big deal. -4 to 4 in both directions. And here's what we're going to do. We're going to do this one together. This will be the last one that we do together. All the rest of the work is your work to do from here on out. What we are going to graph together here is what is f of x minus 3 plus 2. So we're translating both directions on this problem. Okay, we're putting as much into it as we can. So tell me, what two things are happening to this graph according to the notation? Okay, we're going right 3. That's the x minus 3 part. And then we're going up 2. That's the plus 2 outside part. So this is no different than what we're doing. I'm hoping it's no harder. We're just doing both things at the same time. So I'm going to take each of my points and I'm going to go right 3 and up 2. So starting at this end right here, right 3 is 1, 2, 3, and then up 2. This top point, 1, 2, 3, then up 2. The origin, 1, 2, 3, then up 2. This low point, 1, 2, 3, then up 2. And then finally, the right end point, 1, 2, 3, then up 2. So again, translations do not change the shape of the graph. This is the exact same graph we had before. It's just been translated right 3 and up 2. And again, nothing mysterious is happening with the domain and the range. It's just happening in both directions now. When we look at the graph, left and right, what do I get when I add 3 to each endpoint? Well, that means the lowest x value is now going to be -1. And the largest x value is going to be way up there at 7. And notice that's what I get when I shift my original domain right 3. Okay, no different at all. And then up 2, we're looking at the graph. That means my top point here is 6. And then the bottom point is -2. And again, that's what I get when I shift both ends of the original range up 2. You get -2 to 6. Okay, so no differences there. So right next door, again, copying and pasting was not my gig this morning. So we're going to use this graph right here. This is the same thing we were using, you used for example 10 and I think example 4. So these are your points, -4, 0, -2 and +3, 0, 0, 2 and -3, and last but not least, 4, 0. And that's like the little curvy curve that we had before. Looks something like this. So that's just the graph that we were using earlier in example 10. And so if you would do me the favor, please, of now identifying the graph of g of x plus 4 minus 6. All right, so I'm taking this graph, the x plus 4. I'm hoping everybody said, oh, that means we're going left 4 units. And then the minus 6 means we're going down 6. So we're going left 4, down 6 with each of the points of the graph. So left 4, 1, 2, 3, 4, and then down 6, 5, 6. Then left 4, 1, 2, 3, 4, and then down 6 right there. The origin, left 4, and then down 6. Great. This low point, left 4, and then down 6. And then finally, this point over here, left 4 and down 6. And here is my translated graph down here at the bottom left of the Cartesian plane. And then the domain and the range, you can either identify from the graph, or you can identify from taking the original domain and range, left 4 and down 6. So when I take the original domain, left 4, I get minus 8, and then it ends at 0. And you can read that from the graph. And when I take the original range, down 6, I get negative 9, and then negative 3. And again, you can read that from the graph. Both of those should agree. There should be absolutely nothing different. All right, we're approaching the finish line of our time together. Okay, we just got a few more problems to do. So if you have any questions or issues, I need you to let me know so that we can get them cleared up before you go. So we're going to go to the last page. We're going to go down to example 17. So here's what I want you to do, two-step process. Example 17, I'm going to give you 30 seconds. I want you to reproduce the basic absolute value graph. Do that first. Okay, just reproduce it right there. More practice. Example 17. Do it kind of light on your page. All right, so my absolute value graph, remember that's just the V. You could have looked to the front page and refreshed your memory. So absolute value of 0 is 0, absolute value of 2 is 2, absolute value of 4 is 4, absolute value of negative 1 is 1, absolute value of negative 3 is 3. It doesn't matter what points you picked. We both got this V shape right here. So this is my graph of the absolute value. Now, my hope is at some point in the future, you can get to the point where you can do the translations without drawing the basic graph, but don't be shy. Do whatever you need to do. So now what I would like you to do, that we've graphed the basic graph, I want you to graph the absolute value of x plus 2 minus 4. Okay, right there on that same Cartesian plane, absolute value of x plus 2 minus 4. And once you've done that, identify the domain and the range of that new graph, please. All right, just so that we all know, we're doing the same thing here. What two things are happening to my absolute value graph? Okay, we're going left 2. The x plus 2 means let's go left 2. And then the minus 4 means we're going down 4. So that's great. So I'm going to take all of my basic points, whatever I identified there, and I'm going to move them all left 2 and down 4. So however many you need to do, left 2 and then down 4, boom, left 2 and down 4. The origin, left 2, down 4. Here, left 2, down 4. And finally, this point right here, left 2, down 4. I should still have my V shape. It looks exactly the same as it did. It has just now been shifted left 2 and down 4. So there's the graph. And now what's the domain of that graph? How far left and right does that one go? All real numbers. So I'm going to write that as negative infinity to positive infinity. That's what the arrows tell me. The range, what's the lowest y value of my new function there? It's been moved down 4, so it's negative 4. And then up is infinity. And so my range is negative 4 to infinity. If you got a question, ask it. Otherwise, go to example 18. I'm going to give you 25 seconds. I want you to reproduce the basic square root graph, please. Your basic square root graph. All right, so here's what you should have. The square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3. So here's my square root graph. And maybe you already started doing this. If not, that's fine. I want you now to do the square root of x plus 7 minus 2, and then identify the domain and the range, please. Okay, so on this problem, what 2 things are happening to get my new graph? Okay. And down 2. Okay, so my final question for this class. Does anyone not see where that's coming from? Okay, that's important. We are going to use these the rest of the semester, I promise you. All right, so I'm going to take that square root graph that I have. I'm going to move the whole thing left 7 and down 2. So the origin, I'm going to go left 7 and down 2 to right here. The point 1, 1, we're going to go left 7 and down 2 to right here. This point that is 4, 2 is going to go left 7 and down 2, so right here. And last but not least, this point's going to go left 7 and then down 2 to right there. And so here is my new graph. The shape does not change. It's still the square root graph. It's just changed positions. So the domain, what is the lowest x value on this graph? Okay, -7. What's the largest x value? Infinity. It goes on forever. Great job. And then the range, what's the lowest y value of this graph? Okay, -2. What's the largest y value? Infinity. It's climbing slowly, but it'll eventually get to infinity. So there you go. There's your finished product.